Okay, I want to begin by explaining what Snell's law actually is. And to help you remember what Snell's law is if you remember it this way, it's Snell's law of refraction. You'll always remember it has to do with refraction. Okay, and basically what it does is it quantifies the refraction as far as whether the incident angle is larger or smaller than the refracted angle. So it's a quantitative analysis of the refraction. So there's a couple of scenarios that have to be present for refraction to occur in the first place. First of all, there has to be some kind of an angle, okay? The beam cannot come down at 90 degrees. So we have to have an angle. That's the first factor in refraction. And the second factor is we have to have two propagation speeds that are different. So propagation speed 1 cannot equal propagation speed 2. Okay? You have to have both of these factors, otherwise you will not have refraction. So let me explain why you won't have refraction if you don't have an angle or if the propagation speeds are equal. So let's start off saying that the beam were coming in at no angle. It was coming straight down, okay? The beam has a thickness to it, and I think this is an important thing to remember. If the beam was razor thin, we probably wouldn't have refraction. So as the beam's coming in, okay, even if the speeds are different, let's say it comes in and propagation speed 1 is 2000 and propagation speed 2, oops, I see a little mistake here, this should be 2, is 1540, it's both sides of the beam are going to hit at the same time and they're going to hit something that's traveling slower. So the beam's going to slow down, but it's not going to refract, okay? And again, the main reason is because both sides of the beam hit at the same time. The reason you don't have refraction when the propagation speeds are equal, such as in this scenario here where you have propagation speed 1 is 1540, propagation speed 2 is 1540. Okay, when the beam is coming in at an angle like this, and the black lines are showing you how the beam comes in. Now what happens here is, again, there's two sides of it, but this side is traveling still at 1540 as well as this side. They're both traveling at the same speed. So the beam doesn't refract or bend when the propagation speeds are equal. So let's talk about when it does occur. Okay, and we'll start with the scenario here in red, and I'll try to match that color here. All right, if propagation speed 1 is 1540 and propagation speed 2 is faster at 2000, as the beam is coming in, okay, again, the red line represents this scenario here, one side of the beam is hitting a speed that's faster. See, this side of the beam is going to travel faster than this side. By the time this side catches up, the beam has changed positions and turned in a direction away from normal. So what Snell's law quantifies, it says if propagation speed 2 is greater than speed 1, then the refracted angle is to be away from normal in the scenario such as this. And this angle right here, the refracted angle, is going to be larger than the incident angle. And then the opposite is true. If you have a propagation speed, and let me try to match that color, where propagation speed 1 is faster than propagation speed 2, by the time this beam hits this side here is hitting something slower than this side. So the beam is going to travel faster on this end, and the refracted beam is going to be towards normal in this direction. And the refracted angle, which is this angle here, is smaller than the incident angle. So basically, Snell's law says if propagation speed 2 is greater than propagation speed 1, then the refracted angle is going to go away from normal, and the refracted or the transmitted beam is going to be greater than the incident angle. And the second part of Snell's law says if propagation speed 2 is less than propagation speed 1, then the refraction is going to be towards normal, and the refracted angle, also sometimes referred to as the transmitted angle, is going to be smaller than the incident angle. Now, I want to make sure you see these angles here. When we're talking about angles, we're talking about measuring it from normal. So if this is normal here, we're measuring the beam from here to here. This is a greater angle than here. This is probably, let's say, maybe a 40-degree angle. If we were guessing, we'd need a protractor to figure that out. But this is something more like a 60-degree angle. So just to make sure you see the angles we're talking about. And with the red angles, something like this here is a much greater angle. This is probably about a 70-degree angle or a 75-degree angle. And this is, again, still 60 degrees. So sometimes they refer to this angle as the transmitted angle or the refracted angle. Now, refracted is always better, but when that isn't an option choice, then you go with transmitted angle, because it's the transmitted angle that refracts when you have an angle and two propagation speeds that are not equal. This only can occur with these two conditions present. Okay, it has to have both of these. So hopefully that clarifies it a little bit for you. So again, remember it as Snell's law of refraction.